Okay, let's dive into this. If you've spent any time at all with an AI coding assistant, you know exactly what I'm talking about. 1 minute, it's a mind-blowing genius, solving problems you've been stuck on for days, and the next, it's just bafflingly useless. So today, we're going to unpack this coding paradox, why these incredibly powerful tools can be both brilliant and terrible, often at the tasks you'd least expect.
I mean, this quote from expert Chris Hay just nails the frustration perfectly. You're in the zone, you ask the AI to do one more simple thing, and it just quits. It gives you some excuse about its context window or just plain gives up. And as he says, if a human junior dev did that, they'd be out the door. So what is going on here? Why do these super advanced models sometimes feel so, well, lazy? And this really gets to the heart of what developers are calling the barbell experience. It's not a nice, smooth curve of what it can and can't do. No. Instead, you're living at the extremes. You have these incredible, jaw-dropping successes on one end, and then these head-desking, frustrating failures on the other, with almost nothing in the middle.
And just look at this. This is a perfect, real-world example from developer Gabe Goodhart. On the left, a task that seems pretty straightforward, right? Building a command line tool. The AI spit out code that looked amazing, but it was totally fake, completely non-functional. It took him a whole week to fix what the AI did. But then, on the right, a monstrously complex task, optimizing some super obscure Apple code that a human expert was stuck on for months. The AI nailed it in under an hour. It completely flips our entire intuition about what's hard and what's easy.
So that's the central question, isn't it? How can something be so incredibly smart and yet so dense at the same time? Well, it turns out the answer isn't just about the AI's raw intelligence. It has a lot more to do with how we, the humans, work with it, and, more importantly, the systems that are built around it. To really get to the bottom of this paradox, we have to start by rethinking our own role in all of this. See, this isn't really a story about developers being replaced. It's a story about our job description getting a massive fundamental update. Chris Hay asked the single most important question right here. If the AI is writing the code, who's the architect? Because if you just let the AI make all the big picture decisions, which framework to use, how to structure the whole project, you're going to end up with something that looks really impressive, but is actually a total mess under the hood. And this new way of thinking is the key. The developer's job is leveling up from being just a coder to being the project's lead architect. You're not just laying the bricks anymore, you're designing the entire cathedral. Your job is to have the vision, to set the ground rules, and to tell the AI how to build, not just what to build. It's about thinking in terms of strategy, not just typing code.
People are starting to call this new workflow chiseling, and it's a perfect analogy. The AI is amazing at generating the raw material, this massive, rough block of code. But then, the human architect, that's you, steps in with the creative vision to direct it, to refine it, and to slowly chisel away until a polished, final product emerges. It's a real collaboration.
So, what does this actually look like in practice? Well, it means you have to start making your project's architecture explicitly AI-friendly. You can't just have a design doc buried in a folder somewhere. Instead, you create files right inside your project, maybe something like an agents.md file, that gives the AI crystal clear instructions and standards to follow. That way, it builds what you actually envision. But, the human architect, that's only half the story. To solve the other half of this paradox, we've got to look at the technology itself. Because the AI model, that raw brain power, is actually just one piece of a much, much bigger system. Think about it like this. The language model is the engine. It's got all the raw horsepower, all the intelligence. But the performance you actually feel when you're driving comes from the car that's built around that engine, and that's the tooling. It's everything from how it plans a task to how it recovers from a mistake. You can have a world-class engine, but if you put it in a terrible car with flat tires, you're not going anywhere fast.
And this right here is exactly why two different AI tools, even if they're using the exact same underlying model, like a GPT-4 or a Claude 3, can feel like they're from different planets. One feels like a genius, the other feels like a klutz. And the difference is that tooling layer. How good is it at looking at a massive code base? What's its game plan for a complex, multi-step job? What does it do when it messes up? These system-level choices are what separate the truly great tools from the mediocre ones.
As Gabe Goodhart puts it so well, the experience you have isn't just about the model. It's the combination of the model's quality and the quality of the system built around it. It's that synergy between the engine and the car that makes a tool feel like it just works.
Okay, so if that tooling system is so critical, it brings up a massive question for the entire software industry. What does this all mean for the world of open source? Can a flexible, community-driven approach really compete with these tightly integrated, closed systems that the big labs are building?
This table really breaks down the trade-off. The closed systems from companies like Anthropic or OpenAI have this huge built-in advantage. They can develop their model and their tooling at the same time in perfect harmony. They can tune the car specifically for their engine. Now, open source offers incredible flexibility. You can plug and play any model you want, but it faces this monumental challenge of building a universal car that works perfectly with every single engine out there. That's a much, much harder problem to solve.
But here's the twist. As hard as that technical challenge is, the biggest barrier for open source right now isn't actually the tech. The open source models are getting seriously good. The real roadblock is much simpler. It's money. It's all about economics. And here's the problem in a nutshell. Those closed tools, they offer you a simple, predictable subscription. You pay a flat fee every month and you can use it as much as you want. But most open source tools, they have to connect to models using APIs where you pay for every single use. For any serious developer, those costs can skyrocket and become completely unpredictable. So you end up getting locked into the subscription world not because you have to, but because it's just so much cheaper.
But, and this is a huge but, the entire game changes the moment these models get small and efficient enough to run directly on your own machine. As soon as that happens, the cost to use them, the inference cost, plummets to zero. And just like that, the huge economic advantage of the closed systems, it just vanishes. And open source can finally compete on a level playing field.
So where is all of this going? We've untangled the paradox, we've redefined our own role as architects, and we've seen how the tooling and the economics are shaping this whole new world. So what's the next chapter in the story?
Well, what we're seeing right now isn't just a new tool. It's the next major step up the ladder of abstraction that programming has been climbing for decades. We went from typing in assembly to higher-level languages like C++ and Python, and with each step, we got to communicate what we wanted more directly. So what's the next logical step? Communicating our ideas in plain, natural language.
And the way we work is about to evolve too. Right now we have a single AI assistant that we have to constantly babysit and chisel. But the future that's quickly coming into view is one where we have a whole fleet of autonomous agents. You won't be micromanaging a single tool anymore, you'll be managing a whole team of specialized AI agents, delegating entire projects to them. When you think about that ladder of abstraction, it really puts this whole moment into perspective. Every time we've climbed a rung, developers have had to learn a completely new way of thinking and working. So, as we move past writing code line by line, what is that next high-level abstraction that we are all going to have to master?
And that really leads to a profound shift in how we even think about our work. For generations, software has been about people working with other people. But as these systems get better and better, as they evolve from a single assistant into an autonomous team, the choice you'll face is a fundamental one. Will your most effective coding partner be another person, or will it be an entire team of AI agents that you can command